I'm James Denny, and this is my Enme 51 Lab 4 makeup video. So for this circuit, there's just 4 LEDs connected to a potentiometer, with each of them corresponding to the sampling frequency. So this far right one is 500, this one would be 200, 142, and 100. This is just the current setup for the first part of the lab, but if we were doing the square wave part, there would also be a second wire going to pin 11 for the tone function. This is my table. So from my code, I got pretty close to the actual sampling frequency for each of them, only being slightly off. For the delay, it's just sampling frequency, or 1 over sampling frequency times 1,000 milliseconds. Nyquist frequency is just sampling frequency over 2, and the Nyquist rate is just 2 times the corresponding frequency for each of the tests. For alias frequency, you just divide the current frequency over the Nyquist frequency, and then using a folding diagram, get the corresponding alias frequency. So this is the filled out table. Generally, for the 500 hertz as the sampling frequency, there's a lot of deviation between experimental and theoretical alias frequency. But for the rest of them, they generally follow it pretty well. So here are each of my screenshots. So this is for the 75 hertz sampling frequency, or 75 hertz, 500 hertz sampling frequency, 200, 142, and 100. For 100 hertz, you're sampling at 500, 200, 142, and 100. 215 sampling, or 215 hertz, 500 sampling, 200, 142, and 100. And for 300 hertz, here's sampling at 500, 200, 142, and 100. So just generally, it just looked like whenever the sampling frequency was 2 times the Nyquist frequency, you saw that there was a 0 alias frequency, which makes sense because that's how Nyquist frequencies work. And whenever this happened, it seemed like the graphs corresponded pretty well with our theoretical values. But for 500 hertz, for some reason, there was a lot of deviation, and that can either be due to my initial, or my experimental sampling frequency being 6 hertz off from my code, or something that had to do with the hardware itself. But besides 500, it looks like the values generally follow pretty well. I unfortunately wasn't able to get the graphs for the square and triangle waves. I forgot to get the screenshots. But generally, for the square wave, there were major peaks at 20 hertz, and every 20 hertz after that, there were peaks. And for the triangle wave, there were major peaks at 10, 15, and 60 hertz, with peaks at every about 30 hertz. So yeah.